internally it has decoder. So let's count again. So I think I'm something wrong here. So what was wrong? Okay, fine. No, it's 8, but it should show 1. So where's the mistake? Can you find it? I could not figure out this one. Should be external connected to input B. So actually we did this one, right? So we connected to B, C. So where's the mistake? So let me restart this one. I don't know what's going on, but something wrong here.
Can you show the lecture?
Slide, do you mean?
Yes.
Maybe the pins of LED are inverted, like, can you show the properties of LED in multisim and check whether the pins are correctly connected?
No, this last one should be connected to the A, B, so I already think it's... maybe this one should be connected here, so let's check. Okay, so let's check. No. This should be like this A, this B, this C. Okay, this. Okay, now Sims is working properly. Yes, fine. Thank you. Okay. So if I will count, you can see that it will. So let me connect, not this one. Let me just remove. Guys, and I will just connect my generator here. So I do not need to push. So here you can see it will count, right? Guys, I have a question for you. How can I wire that it will count not up to the fee, but up to the 10? So it's from 0 to 9. How can I wire? Can you have some suggestions? So let me open this.
Up to 10 or up to 9?
So we need to do this counter, decade counter. So it should count from 0, 9, and after 9 it should come back to the 0. What do you think?
The last and the third connect to the AND gate.
So R1, for example, where should I connect R1?
NAND gate.
Yeah, R1, it's actually the input of the NAND gate. So I should connect it somewhere to D, C, or B, or A. Where?
PNG. Oh no.
Yes, right, D, and also this R2 should be connected, I think, to B, right? So let's check.
Yes.
So fine, actually you can, play around at home and try to, for example, count for up to 7, so it's actually up to you. Okay, so let me, no. Reopen Multislim. So guys, let's continue. So pin, when you work with the real hardware, of course, you need to look carefully on this pin and understand what is a 1, what is a 2, and so on. But in the Multislim, we do not need actually this scheme. Okay, so this is still the 7493. So I already explained how it works, so we do not need to carefully look at this. It's just truth table and just reset count function table. So here you can understand if it will be high on the R1 and R2, it will clear, yes, and we'll have 0, 0, 0, 0, 0, 0. So when the R1 or R2, some of this pin will be low, other we don't care, it will count. So next, let's consider the 74192 up down decade counter. Actually, it's very complex. So here I will not show its logic diagram because it's very complex. So this counter actually is synchronous counter, which can count up or down. So here, actually we have two designs. So it's a dual inline package, but there is also other kind of design. So of course in Multislim we don't care. And here you can see the Multislim version of this up and down decade counter. And just consider on the waveform how it's work. And so actually, I think it's better to show on the Multislim, but anyway, let's consider this first. You can see this parenthesis. So actually it will clear output to 0. So you should look carefully what will be A, what will be B, C, D. If you look at the next, this one, it will load preset to BCD. In this example, it will be 7. Count up to 8, 9. So here, in this region, it will count. And here, in this region, it will count. It's count down. Here it's up and down. Okay, so let's consider this one on Multislim. I will open. So guys, this one. Yes. So let me explain how it works on a real simulation, right? So when I start, can you see I already have some digit because, okay, let me close this one. Restart. So I will clear. It will be 0. So guys, you should understand that this input clear 14 pins. So it's a synchronous input. So doesn't matter what will be other ones. If you will click this one, so it will always clear the output to 0. Okay. So next, consider what is this load means. So you can see here bubble. On the it's 11 pin, right? You can see here bubble. So it means you activate this load input. You activate by low. So now it's connected to high. So when I press, I actually activate. So when you press to the load, then you can put here some number. For example, if I want 8, I just press D. It will be 1, 0, 0. So it will be 8. But I can, preset input only when load is activated. For example, if I will deactivate this one, then it will clear. If I want, for example, 9, you can see 100 should be 9, but it doesn't work. For this, I need to load. I need to activate load. Only this key. So this load input we need in order to preset some value. For example, now I preset 9, right? Then I need to deactivate this one. So I deactivate. Then I can count up or down. For example, if I connect the input down to the clock signal, so it will count down. So here, guys, you can see it. Okay, let's stop it. And for example, now I can count up. Can stop and clear. So what you should know? You should know that you can clear by the applying to this 14 pins high. Then you can preset some outputs, but for it you need to first click load, you need to activate load, then preset your value, then you need to deactivate, because it will deactivate, it will not count. For example, now I activated it. For example, I need to close this clear. So now my input is 4. It's 4. 1 1. Something strange is here. Okay, let's put to the 0. Okay, now it will be 7. Now I could not count up or count down. Why? Because my load is activated. I need to deactivate this load. Now I can count up or I can count down. Okay, so all of this actually explained here in this waveform. So please, guys, when you will read, look this presentation, read the chapter 8. So look carefully and try to understand, because it's very useful to understand this. But what else I want to show you, explain? I want to explain the outputs. Here you can see we call borrow and carry. So what's the meaning, guys? So let me increase. So let's count up. Guys, look on this B and C outputs. So, for example, now it's 7, 8, 9. Can you see? This C is carry is changing when it's after the 9. It's changing. Can you see?
Yes.
Okay, so let's count down. Now I will count down. So look to the B, borrow. Can you see it's changing? So actually it's additional output. It's needed. For example, I want to make the counting not to the, for example, 9 to 10. For example, I want to count up to 100. So I will put these two screens. I can connect. We call this cascading. Actually, I can connect this, for example, input here, and actually it will trigger this one. So it's just, you know, to increase the number of outputs. This one, it's very useful. Okay, next. So we consider just TTL, and now, of course, there is CMOS integrated socket counters, and I will not show in the multi-slim because they pretty similar to the ones that I just showed. So, but you need to read on the chapter 8, and tomorrow on the lab you will work with some of this. So one of this is 74HC393 4-bit binary counter, and next one 74HC193 4-bit binary up-down counter. So it's just 4-bit binary counter, it's up-down counter. So here you can see for this first one, what's this 393, you can see this how it's, look inside. Here you can see it consists of two, actually this integrated circuit consists of two counter, right? 4-bit 2 counters. So actually you can cascade, connect it together. And here you can see the truth table, how it works. So here we need to pay attention to this designation. CP, it means clock. So just some manufacturers, they just name clock by the CP. So here you can see the overbar. What does it mean? It means that it's negative triggering, because we have positive triggering and we have negative triggering. So this overbar means it's negative triggering. Also we have MR, it's master reset. It's just clear. It will just clear your output to 0. So please read on the chapter 8, and tomorrow you will work on labs. Maybe this one or next one. Okay. So if we're still considering this one. So if we look inside of this 4-bit counter, you can see that it consists of 1, 2, 3, 4 T flip-flops. What is a T flip-flops? Actually, T flip-flops is a GK flip-flops, but in toggle mode. When your G and K internally connected to the VCC, we say this flip-flop T flip-flop. So actually, it's just GK flip-flop in toggle mode. It's a pin diagram. But in multi-slim, it's not necessary. But in real hardware, of course, you need to understand how to work with this pin. So next, it's 74HC193 4-bit binary up and down counter. It's very complex inside, so I will not show the logic diagram of this one. Here you can see some function diagram. So it actually has 4 input, 4 output, but also you can see other output. It's just similar to the borrow and to the carry, just for cascading to connecting with other counters. So it has 2 clocks input, CPU and CPO, and also PL. So what is a PL? So let's consider asynchronous parallel load input active low. Okay. Asynchronous parallel output. So when it's low, you can give some input. Here, for example, if it's 0, you can, for example, apply any inputs, and in the output you will get those inputs that we apply. But in the case when this is 0, when it's high, this input will not work. So it's similar to the previous ones that I just showed on the multi-slim. So also you need to pay attention to this MR, just kind of, clear, just reset your outputs to 0. So this CP and CP is just clock. You can see that it goes without overbar. It means it's positive triggering. So it's very important to understand. Okay, so it's truth table. So actually it has, you can see 4 operation modes. Reset, clear, you need to activate MR master reset. It had parallel load, you need to apply to this PL, 11 pins, you need to apply low. In this case, you can put input, and this output will show you this input when this is low. Also, it has count up and count down features. Okay, guys, so I think now we can do some little summary. For now, we considered actually a lot of scheme, a lot of simple digital systems, and actually we can divide any digital system in how much? 5 parts, right? So we need some input. So we need interface input with some digital processing system. So digital processing system can be some combinational, sequential, or both. Then we need to connect the digital processing system part units with the outputs. For it we need some interface, and of course we need outputs. So what kind of inputs have we studied? We work with switches. You assembled multivibrators. In some chapter, I do not remember, we studied Hall effect sensors, we studied some pulse width modulators. Also, what kind of outputs we learned? We work with LIDs, 7-segment displays, some buzzers, relays, motors, stepper motors, servo motors. But of course, there is a lot of other inputs and outputs. And of course, in this course, we could not cover all of them. But step by step, we'll introduce new type of inputs or outputs. So today we'll consider new type of input. We call it the optocoupled interrupter model. So actually, it consists of two parts. So here you can see it can be like this. So it consists of some transistor, we call it phototransistor, and some LID. So how it works? So let me show you better on the multi-slim. Here I should have, yes, okay, guys. So let's apply to the LID. We connect our LID to the VCC. Of course, we need some resistor to restrict current. So I need to run. So this LID now should light, but it doesn't have this kind of simulation. So for this reason, I just added this probe. So it means when this probe is lightning, it means this LID also, light. Okay. So this LID should be, for example, green, yellow, but mostly for these devices people use infrared. So it means light in the infrared region. Of course, our eyes could not detect infrared regions, but phototransistor can detect. So actually, when our LED is biased, when I apply voltage, so now you can see it shines, it lights, and it illuminates this phototransistor. So now its phototransistor is opened, and current can go through this from this. We call this part collector. It's emitter. So current goes through this collector through the emitter to the ground. Here you can see 0. When I switched off, you can see 1. So actually we can use this. If I will come back here, if we will interrupt here, put, for example, your hand, maybe something, when you block the light, when you block here the light, it means that you switch off. And you can see that output will change. So we can use this device, for counting some events, for example, some interruption. And let me show you the interesting circuit. This one. And stop this one. First, let me show you on the slides. So guys, here you can see other new type of digital system, actually, that can count, for example, some interruption. Here you can see some disk, we call it, and you can see that in the, we have some hole here, right? Some slots, and it can rotate. When this slots go through this interrupter, it means that LED illuminates the phototransistor, and phototransistor activated, and on the output we can get some signal. When it interrupts by this part, it means that we block light and phototransistor is switched off, and our output signal will change. So actually we can count some event Okay. For example, you can use this for counting how much people will go through this some door. For example, here can be some door. So you put your phototransistor on the left side of your door and the LED on the left. And when people go through this door, it will block the light, and your you will switch off, switch on the phototransistor, and actually you can count the number of people that go through the door. And let's see this one in my circuit. So guys, actually here I'm using 74192, and you can see I connected it together. I explained to you that you can use this carry outputs. You can connect to the clock of the second integrated circuit, and actually you can, increase the. So at first it was 4-bit, but cascading by connecting it together, now you can see I can count 8 bits, right? So for example, let's imagine that here people go through this door, and I can just count this amount of people that. So it's simple, counter that will detect interruption. Is it clear, guys? Do you have any questions?
So is it like opto-isolator?
Yes, it's like opto-isolator. So function is the same. So, but we call it opto-coupled. Yes, good questions. The working principle is the same. But what's the difference? If you look at the here, here you can see that LED part and the phototransistor part is separated, right? But in the opto-isolator, they all in the same inside of the same, box. So you could not use this as interruption devices, but principle of working is the same. Okay, next, what I want to show you guys. Let's continue my slide. So actually, we can count some real-world events. For example, how much people go through this door, for example, right? But now I want to show you some interesting games that actually now we, actually we'll come to some point when we can assemble some simple electronic game. Okay, guys, I will switch in Russian because I want to play with you some game. Ребят, сейчас мы дошли до такого, в общем, уровня, когда мы можем, в принципе, собирать что-то интересное. И здесь схема простой игры. Да? Игра называется «Угадай число». И сейчас я хочу запустить на своем мультислиме и, давайте поиграем игру. Угадать надо будет число. Давайте где-то 3-4 желающих. Who wants to play the game? В общем, задача такая. Let me at first explain how... What? Can you repeat the question? Okay, first let's explain how it works. So, guys, it is a binary counter that we just considered. It's some generator, just generate some random number. For example, when I press some inputs goes to this binary counter, and this binary counter will count and will apply the output to this comparator. Now, we did not study yet comparator, but we'll study later. Then this comparator can compare the numbers that you apply. Here is the number that you apply. And this is a number that randomly was, just randomly was put it to this binary we put to the binary counter. Then it compare, for example, if your chosen number and the randomly generated number is the same, it will be green. If your number is higher, it will show red. If it's lower, it's yellow. Is it clear? Понятно, как это работает?
Yeah.
Okay, let me open on the multislim. So guys, let's start. So you can see that my gain is my number is 9. Okay. So first it's 0 and input also 0. So I press and now counter will count something. So you can see that the frequency is too high. So actually it's randomly count. It counts something, but we don't know how much. Какое число здесь мы не знаем. So your task is to guess, угадать. So what do you think? What's the number? So for example, let's guess 9 or 8. You can see it's still lower, right? For example, in this case, 9. Of course, it's lower. So what will be C in the decimal? Guys?
So, 12.
So what in decimals is one?
15 or 16. Like, no. 14.
Okay, let's use calculator because I don't want to think too much. But
14.
of course, it's better to remember. But anyway, let's use the programmer and just hexagonal, right? And it shows us E. In decimal, you can see it's 14, right? Okay, let's me restart. Okay, guys, who wants to play? Давайте выберем, ну, не знаю, троих или 4 игроков. Кто за меньше шагов угадает число, тот получит оценку хорошую. Договорились? Кто хочет участвовать?
Можно?
А кто? Тайп, напиши свое имя, а то я сейчас... Кто это у нас был?
Макжан.
Макжан, хорошо. Смотри, я буду сейчас генерировать какое-то число. Твоя задача сейчас... В общем, ты угадаешь, после тебя кто-то будет другой участвовать. Кто за меньшее число шагов угадает, тот получит хорошую оценку. Ну, давай. Какое число?
Окей.
Окей. Так, один шаг. Ты уже... То есть один шаг использовал. Дальше говори.
4.
Так, same in binary. 4, сколько будет у нас в binary? Шесть. Okay, 2, 3. I think this, no.
100.
1, 1, 0. What will be 4? It's 3 and...
100.
100 is.
Yes, 100, sorry, guys. Второй шаг ты использовал. Next.
2.
Same in binary.
2.
2, okay.
In binary.
Окей,
Ten.
2. Маршан, ты сказал, да?
Yes.
Окей, то есть, смотри, на третьем шаге ты угадал. Кто следующий хочет? Если вы как бы быстрее, чем Маржан угадаете, то есть вы получите оценку хорошую.
I want to.
Who is it?
This is Damir.
Damir. Okay, Damir, let's generate. Okay, so your try.
I think it's 8.
8. Okay.
Yes. This is 8, yes?
No, it's lower. То есть твое число наше ниже. It's lower.
No. But on the screen, what is? Like,
Ты же сказал же 8, but он не совпадает. Это число, оно меньше, чем 8.
6.
So 6, it will be this one.
For 2, yes.
So it's still lower.
Like 4?
Так, это уже третий твой шаг, смотри. 4, окей.
Yes.
No,
it's 3.
It's one, teacher, it's one.
Так, подождите, какое число ты сказал? 4?
2 сказал. 1.
Нет, ты 4 же сказал.
100.
Ну там 1, да? Ответ.
Так,
Или
подожди, это какой шаг у него уже? Что-то я запутался.
Нет, там
2. Там нету, вообще не показывайте. 0 еще?
Zero, teacher.
Не,
Третий
подожди,
шаг.
сейчас же играет же Дамир же.
третий шаг. Да?
0.
Дамир, это какой шаг был? Это же был третий шаг.
4.
Давай,
Дамир,
сейчас пойдет. С какой
Дамир,
числом?
Дамир, там
Третий.
твое число меньше, чем заданное.
Да, там наоборот.
Ты не
понял?
Должен больше
Ты наоборот.
число брать.
Да.
Ну да, я же сказал 0.
0, да? Ну давайте 0 поставим. Все, Дамир, в общем, ты все равно не смог. Давайте угадаем уж
А
какое
что за
число.
число там? Ниже 0?
Наоборот, там должно быть больше, то есть твое число меньше, чем вот то, что... Нет, твое
Да,
число,
заданное.
то, которое ты ищешь, оно наоборот больше, чем
равно
твое.
чуть lower. The number is lower. Like when I said
Ну вот,
8,
смотрите, и вот давайте поставим самое большое число 16. О, 16. Все. Так,
С трех
все, Дамир, в любом случае ты не смог оббить Маржана. Следующий кто?
Можно?
Кто? Это?
Санжар.
Санжар?
Да.
Так, давай, Санжар,
С трех
генерируем.
попыток, да?
Ну, ты должен, получается, Маржан же с 3 попыток угадал. Тебе надо будет, если ты сейчас угадаешь с 2 попыток, значит, ты выиграл.
Хорошо. 8.
8? Так, 8, ребят, это вот это же первое нажимаем.
То есть число больше, чем 8, да?
Да.
Так, 8, 9, 10, 11, 12, 13, 14, 15, 12, maybe.
12. How much it will be on the... I don't want to think,
speed.
guys.
Speed.
8 and second.
Okay, let me switch to the... I don't want a mistake.
110.
Let me... to decimal. Ты сказал 12, правильно?
Да.
110.
Ага. Ну, я все равно проиграл, да?
Ну да. Не, подожди, это второй шаг же, да, был?
Да.
Ну, если сейчас отгадаешь, тогда 1-1 надо будет переиграть.
Ну, ладно, тогда... Так, 8, больше 8, меньше 12, может быть 9, 10, 11, да? Ну, давайте 9.
9?
Да, первое и четвертое.
Да, первое, четвертое. Так. Так сделаем, да, и это поднимем.
Проиграл.
Ладно, Маржан, ставлю тебе 100 баллов. Окей. Guys, how much we have?
Правда?
100 минус.
So we have still time, okay? Ну, вы поняли, как он работает? Have you understand the idea how it's work?
Yeah.
Okay, so let me explain again. So here, when I press, this one. So signals a lot of impulses goes to the counter, and counter will count. Okay, when I'll stop and we'll stop count, and here on the output we have some number in BCD, of course. Then this comparator is comparing. Can you see this coincidence? So you can see it says output is 9, and here input is also 9. So comparator is comparing, and you can see it's show that they're equal. Okay.
То есть, а можно вопрос задать? То есть, когда мы play нажимаем, можно посчитать, да, сколько раз эти лампы загораются?
Нет,
такое же число?
не посчитаешь, потому что здесь частота 1 килогерц. Это считай, что в секунду 1000 импульсов входит.
Можете запустить?
Нет, он просто так показывает, это он просто не успевает компьютер.
Окей.
Okay, so guys, let's continue. Still we have time. So I've explained how this works, but here you need to look carefully for the comparator. So it's a comparator. We will study in detail later. So it also has cascading inputs. Actually, you can connect two comparator together and you can compare, not here in this example, we compare a 4-bit number, right? But we can compare, for example, numbers that will be encoded in 8-bit. Of course, it is truth table of the comparator. So guys, now we'll, I think we don't have time, but I want to play with your other game. Guys, you need to read these shift registers. Maybe on the practice class I will also explain, but for now I just want to show you the other game that also you can able to do. I will open. So this game is called roulette, то есть как типа русская рулетка, okay? So after reading the chapter 9, you will understand how can we assemble this simple game. But the key is the following. So I will run, guys, and look, when I press play, it will just randomly circulate and will stop. Okay, I need 8 students, so we will start. We need 8 students, and how can we play? I don't know.
Давайте в чат напишем список.
Who wants to play? Okay, let's do. This roulette will randomly choose any numbers. I just play and will stop on something, but it will stop randomly. So who wants to play? I need 8 students, and who will win? For example, this circuit will choose number 1, for example, 3, 4, and I will grade these students with good grades. Okay, so 8. Who wants to play?
We raised hands.
Okay, Sanjar, you will be first. Ты будешь один. Маржан, ты уже играл. Ершан, ты будешь 2. Запоминайте, ребят, свой номер. Улпан, будете 3. Алдияр, будете 4. Кто еще? Все? Никто больше не хочет оценку получить?
А может тогда, если нас 4 поделим, чтобы больше шансов было?
Ну, я смотрю, остальные не хотят просто оценку получать.
Ну,
ребят,
это их вина.
А? Кто еще? Махмуд, да?
Нет.
Так, кто был у меня последний? 4? Кто был?
Улпан.
Улпан, вы какой номер были?
Третий.
Нет, я был последний, 4.
4. Махмуд будете 5, Тамерлан будет 6. Султан будет 7. Кто еще там играет у меня? Куаныш будет 8. А, все, 8 последних. Куаныш будет 8. Ребята, вы все запомнили свой номер? Я не запомнил. Запомнили?
Да, запомнил.
Да.
Хорошо, давайте. Здесь, в общем, если я увеличу вот этот вот резистор, он будет дольше. Чтобы немножко была интрига, я буду увеличивать этот резистор, поставлю его на 30. И кого он выберет, тот получит 100 баллов. Договорились? Do you agree with it or not?
Yes, of course.
Yes.
Okay. So let's start. Не, почему-то, подожди, сейчас не считается, ребят. Подожди, что-то он не сработал. Почему-то я увеличил, он не хочет работать. Давайте я посмотрю на этот circuit. 47 микрофарад, все правильно. Давайте увеличим на 47 микрофарад.
Может, так и оставим?
Нет, я же отключил, он же не доиграл до конца. Вот сейчас, давайте просто проверю. Я хочу, чтобы он чуть-чуть дольше был, а то быстро это как-то неинтересно. Давайте поставим 60 и посмотрим. Я просто включу, запущу, как он работает. Так. Может, мне просто больше надо держать. Все, let's start. Ребята, это просто тестовый пока, не думайте, я просто смотрю. Что-то он не работает, как я хочу. Давайте я уменьшу. Надо просто быстро нажимать. Ладно, вот сейчас запустим, как есть, так есть. Все, раз, два, поехали. Все? I think it's stopped on 1. Who is number 1?
Me, Sanjar.
Okay, so Sanjar and Marjan, right? So you need to write me, because I can forget that you win the game and you deserve to get 100.
100 for luck?
Just great for the lecture, for the participating in this game.
In Teams? To write in Teams?
Okay, I will add as a part of the lab, okay? I don't know how I will grade, but I will grade this. It will affect your midterm grades.
Teacher,
Yes.
is it Russian roulette? Like,
Yes, it's kind of as a Russian roulette. So actually, how it's work?
the rules are
let's-
not the same, I think.
Not the same, but maybe it's not Russian roulette, but this type of game. I don't remember how Russian roulette is working, but it's a. What's the rule of the Russian roulette?
Like, the winner is last one standing, like.
Yes, yes. So for this reason, we need just remove the other LIDs for this. Yes, but it will take a lot of time. But actually, I think when you will over this course, actually you can create the Russian roulette by using this multi-slim or maybe real hardware example. So okay, let's continue. We still have some time, and let's me explain how much we have. 10 minutes, or it's all
It's
So-
already time.
We've done?
Yes.
Okay, guys, in this case, we just don't have time, but you need to read yourself. Guys, you need